Hello everyone and welcome back to PostNetwork Academy. Today we are diving into two fundamental concepts in probability and statistics, and I have just chosen these two concepts randomly, and we will solve two numericals also. So the first topic is Central Limit Theorem and Uniformly Minimum Variance Unbiased Estimator. So if you are studying probability, statistics or data science, these concepts are a must know. So let's get started. So suppose x1, x2 are IIDs. IIDs means independent and identically distributed. So it means that random samples are independent and they are taken from the same probability distribution. So these are sequence of random variables with common variance that is greater than 0, and two random variables are again defined, yn and zn. So what would be the asymptotic distribution as n approaches to infinity? So here the first option, standard normal distribution, second normal distribution with variance, and third one normal distribution with variance 2 times or degenerated 0. So let us solve step by step. So first of all we have to know central limit theorem, and central limit theorem states that for a sufficiently large sample n, the distribution of sample mean again approaches to normal distribution. This is a very important. So sufficiently large size n, the distribution of sample mean that approaches to normal distribution regardless of the original population distribution. So original population means it may be uniform, gamma, beta, binomial, but its mean will follow normal distribution for a sufficiently large n. So that is the statement of central limit theorem. Now again x1, x2 are independent and identically random variables having mean mu and variance sigma square. So sample mean, we know that just we will add all the observations and we will divide by number of observations. So central limit theorem states that mean of that observations will follow standard normal variety while it converges in probability D for a large n. So here we define yn as this expression. So see that the main thing is that these expectations of these sample means are equal because they are from the same distribution. So what would be their variances? Sigma square upon n, and for this one sigma square upon n, because sample variance is equal to population variance, you can say that, upon number of samples. So see that variance of y minus zn, that would be variance of yn plus yzn. Remember that here variance of variance of yn plus minus zn, that will always equal to variance of yn plus variance of zn. So even it is minus or plus, you will add the variance. So that would be equal to 2n square 2 sigma square upon n, and if you multiply it by under root n, so you will get 2 into sigma square, because see that here variance of this one. So just calculate it. Let us see that. So we will use the formula like this one. Suppose that we have variable x, and if you want to know the variance of ax, so we know that variance of ax would be a square variance of x. So here, because these are this is your variable, so what will happen, variance of this expression would be variance of under root n yn minus zn, and that would be equal to under root n square, and variance of these two, you can say that this difference of these random variables. So we have already calculated, that would be equal to 2 sigma square upon n. So finally we'll get 2 sigma square, because that would be n. So these are very small thing, but you have to take care to solve these kind of problems. So finally, by the central limit theorem, that will approach to, that means that will follow the distribution, normal distribution having mean 0 and variance 2 sigma square in probability D. So third option would be correct, that is n0 2 sigma square. So hope you understood. Let us see one more problem on minimum variance, uniformly minimum variance unbiased estimator. Suppose that these x1, x2, xn be independent and identically distributed observations from normal population. So we need to find minimum, basically uniformly minimum variance unbiased estimator. So we also denote it by UMVUE. So let us see that. So options are 1 upon n xi square, 1 upon n minus 1 xi square, third, fourth, you can see that. So let us solve. So we know that the sample variance that is s square is 1 upon n summation I is equal to 1 to n xi square, sum of all. So we need to find, if we need to find expectation. So here what will happen, expected value of s square, that would be equal to n minus 1 upon n square. So it is not equal to sigma square. That means sample variance is not unbiased estimator of population variance. So that is biased for sigma square. So to correct it, just we will adjust that. Just we will put here. Just this factor we will multiply. So what will happen here? So sigma hat, that means unbiased estimator of population variance. So here that would be equal to n minus 1, and we will plug here s square, so that would be equal to 1 upon n sigma I is equal to 1 to n xi whole square. So we will see that this can get cancelled, and 1 upon n minus 1 summation over I is equal to 1 to n xi square. So this one would be unbiased estimator for population variance. Now let us see. So hope you understood these two concepts. In upcoming videos I will explain in detail, but one thing you should see that the correct bias, just see that the question. So basically I want to show you that this one would be the correct option. Correct option I wanted to show. So this one would be correct option. So hope you understood, and in upcoming videos I will explain these kind of concepts and numericals. You can visit website, YouTube channel, Facebook page, LinkedIn page. So hope you understood. Thanks for watching.